Let's have some fun. This isn't a bad one. This might be the video that you skip over because you're like, shit, power rule, I get it. Let's go. Let's go. It's got a few of them for you. Got the little formula written up. It says that if n is any real number. Oh, by the way, we write that like this. N, the element of the real numbers. So if you ever see that, I won't put it on a test or nothing like that, but this means like element of. Like it belongs to. Like, hey, I'm an element of the teachers at Sierra College. I'm not every teacher, but I'm one of them. I belong to it. I mean, I couldn't be any one of the other teachers. Maybe this is a terrible... Okay, I'm going to shut up now. The element of belongs to the group. That's the real numbers. What you know about the real numbers? Like negative infinity to infinity? No i's. Shit like that. So don't put any eyes up in that, or maybe this won't work. Whatever. Don't stress. Let's get rid of this. Why am I getting so crazy? So basically, we say the derivative. This is written in Leibniz. I know it's kind of rough to read, but it's saying if you have x and it's raised to some sort of power, we can just let that power fall to the front and then subtract 1 from it. Let the power fall to the front and then subtract 1 from it. That's the game. It's not so bad. It's actually the simplest shit we've done. So like there's the power rule. Let's go. So I'm going to start showing you the different notations as well as to how we could write this. Since it says y is equal to x to the 4th, I'm going to write y prime for this one. I could write dy dx, but I'm going to wait for that one for a little while, towards the end. So here's the game. The 4 is going to fall to the front. 4 is going to fall to the front. Cool. Then you write your x, and then we're going to say subtract 1 from the exponent. So you don't need to write that step. Y prime is 4x cubed. That's it. Here's your derivative function. Start off with something to the 4th, x to the 4th. Take a derivative on it, you end up with something 1 degree less than it when we're dealing with polynomials. Cool. Maybe I said I was going to do it later, but we could have wrote our answer like this. The derivative on y with respect to x. That's kind of what we're saying there. The derivative on y with respect to x. Saying y is what we're calling the damn function, and x's are what we're taking freaking derivatives on. And we could say that that is 4x cubed. Wow. All right. Let's get it. So we go to number 2. We got f of x is equal to x to the 1,000th power. So let's say f prime of x, right? Because since we're using an f of x and not a y, we just, just throw a little prime on it. Just like what we do with a y. What we do with a y? We just chuck a little prime on it. We could have wrote it in Leibniz as well. So our 1,000 is just going to fall to the front. And then we subtract 1 from 1,000. That's 999. What? This is it? This is it? Dang, that's some easy shit. This isn't so bad. I try to stay away from the word easy, but I mean, as far as the other stuff you do in this class, I'm not sure there's a better adjective for it. Now, where the trouble comes into this section is this is a big algebra test more than anything, because you're going to be able to pick up on the power rule. You'll be fine. You'll be able to do this. But it's going to be the algebra that's behind everything is where we're going to need to get our practice. So please, just because you're like, I know the power rule, I got that. Don't skip on the homework. This stuff is going to test you more like, how's your algebra? And you got to have them algebra skills as we go on. So keep building that. Let's keep going. Now we got g of x is equal to 1 over x cubed. Now we made the game a little bit more challenging. Because we have a formula for it. I mean, it tells us that, I mean, if we were to have, say, something like f of x equals x to the n, then its derivative would equal n times x to the n minus 1. But that's if it's x to the n. And we haven't talked about 1 over. We're going to have to use our rules. That, hey, we learned this in algebra, and you're probably like, why we learn this shit? Why do we have to know about it? These negative exponents? Let's go. All day long. That's your life now. Exponents, subtracting 1 from them, negative, friggin' fractions. You better know how to subtract 1 like a mofo, okay? Lots of subtracting 1. So here we go. G prime of x g prime of x. We're going to let our number fall to the front. So that's going to become -3. And now we have to subtract 1 from -3. So -3 minus 1 is -4. Now, I don't mind this answer. In calculus, we're not too cranky about leaving a negative exponent. By this point, you're not in algebra and we're trying to teach you over and over and over what it is. But it is a good idea to, if you are not strong with this, to maybe practice and say that this is -3 times x to the -4th. The -3 is not being raised to any power, only the x is. So if you wanted to slap the x, you drop it down into the denominator. So there's two different ways of writing the same thing. They're both correct. Just one is remove the negative exponents. Let's go. Oh shit. What is going on here? Oh. This isn't as easy. But it's no biggie. If we have something here. Oh shoot. Get rid of that. If we were to have some x to the n raised to the nth root, this is equal to x to the n over m. Rational exponents are your friends. Roots suck. Get rid of them. You're going to be subtracting 1. I don't want you subtracting 1 from pictures. Subtract 1 from freaking numbers. And here's the big one. On lock all day long. You must have that. The square root of x is x to the 1/2 power. All day, dude. You gotta know it. You square roots, nah. Get rid of that shit. Alright, so here we go. Y is equal to x to the 3/4. Now we can go find y prime. Or actually, this time, I'm going to write it in Leibniz. Either or. dy dx. Derivative on y with respect to x. So we're going to let that 3/4 just fall right to the front. 3/4. I'm going to write my x in. And then we need to subtract. 3/4 minus 1. 3/4 minus 1. 3/4 minus 1. Well, that's going to be equal to 3/4 x to the -1/4. That's a cool answer. That's a cool answer. I like it. It's a good calculus answer. I mean, we could write it a few different ways. I mean, if you want to get weird with me. Oops. 4 times x to the 1/4. Or I mean, if you really want to get weird, well, just do that and call it the 4th root. I mean, they're all the same thing. It just depends on how far down you want to simplify it or how you like it written. All the same thing. They're all an acceptable answer. I have no issues with a negative exponent, but please check your homework. I'm not 100% sure on how cranky WebAssign can sometimes get with a negative exponent. So there's just a couple lead-ins, just a couple play around with them, kind of get the point. We'll come back, we'll have some more example problems. Maybe we'll talk about tangent lines and normal lines, maybe a constant multiple rule, shit like that. So see you soon.